Our next presenter will be Lapacz from Computer Science of Poznan Supercomputing Center, where he's working for network department, and he's working on multicast monitoring and visualization tools. And he will present us their recent results.
My name is Lapacz, and today I would like to present multicast monitoring topic. We all know what is multicast. Some of you even very good. We know that it reduces network traffic and conserves the bandwidth. Multicast exists in IPv4 and IPv6 networks. And we know also that it is very good for example, video conferencing. But everything is okay, but we have some problems. One problem is that small number of end user have access to multicast. In Poland, for example, I don't know a Polish network that provide multicast for end users. I don't mean scientific users, but normal common users. And second problem, last mile problem it calls. And the second problem is a small number of advanced monitoring tools. We have multicast. We know everything about multicast for a few years, but we still don't have good advanced tools to monitor such multicast-enabled network. I would like to say to present some monitoring multicast monitoring tools. I only list a few of them. We know command line tools, very simple. For example, mtrace, mrinfo. There are some more advanced MRTG to present some graphs of multicast traffic, mHealth, RTP monitor, multimon, and multicast beacon that I would like to focus on it. We have also a few commercial proposals. The most famous of is application from Hewlett-Packard company. I will say something later about this application, but now I would like to present a multicast beacon, because we in Poland do research using this application. What is multicast beacon? Is the application to monitor 5 traffic parameters: basic, loss, delay, jitter, and duplicate. We have here some screenshots of this application. In the right, you can see the matrix of clients of this application that exchange multicast traffic and the parameters of this traffic. Multicast beacon was created in USA in National Laboratory for Applied Network Research. It is a Java application, so it is operating system independent. We can deploy it on Windows platform, Linux, Unix, whatever. the architecture of this application is client-server. Clients exchange packets using multicast, and that's why they calculate traffic parameters. Server collects this parameter values from clients and presents them to the user. We can, on the previous slide, we see the matrix of these clients and values of monitoring parameters. In this example, it is loss parameters, and this application is open source application, so everyone who is interested in developing can download sources and add some new functionalities, some new modules. And we have done some new modules in Poznan. I will present these modules later. It is architecture of multicast beacon in graph form. We can see here server and clients. Clients exchange data using multicast, and server collects values of traffic parameter, multicast traffic parameters, and present these values to user. We have done some new modules in Poznan. Basically, multicast beacon in original form present only current values of traffic parameters. We can't see what happened 5 minutes ago, for example, or 2 days ago. So we created a module to store these parameters and to present them in chart forms. This is this module. We created also a trigger message module, so we can define some threshold, and application notifies user if parameters get some earlier defined threshold values. We added mtrace module, but it is only for IPv4 network, and we use exterior mtrace tool. It is maybe not efficient way, but now it works, so we use it. We also add some improvements to use multicast beacon in IPv6 network. Multicast beacon is created in Java, as I said previously, but there, in original form, there is a problem to present IPv6 addresses on the interface. So we had to add some improvements to present these IPv6 addresses, and we did some code improvements because architecture and structure of multicast beacon is not ideal. We had to improve some parts of this application. Deployment of multicast beacon. We know that multicast beacon is deployed in Jean network. Dante monitor multicast traffic using this application. We in Poland also use multicast beacon, and also in IPv6 network M6 Bone that was presented yesterday by Stig Venas. Also multicast beacon is deployed, and it works nice. So we have some new ideas to improve this application. A few weeks ago we had a meeting in Poland, TFNG and meeting, and a very interesting presentation was provided by Radoslaw. He pointed some new ideas to improve this application. So we see that we must work to make this application better, and there are many new ideas, many new possibilities to enhance this tool. So, for example, we proposed SNMP interface to let other application to request for multicast traffic parameters. We also now we are developing a new protocol to communication between clients and server. Now, if we need to change this protocol, it is a problem because all networks, all people who deployed clients in their networks need to download new version to have this new protocol. We propose to include new functionality. We call this version auto configuration. Client checks version being used by the server, and if the version is new, the client can download this version and from that moment use it. For communication, we will use XML format. A very popular topic now is grid topic. We found multicast beacon as very useful in the grid architecture. It is natural for, in my opinion, for beacon, because beacon consists of many clients, and these clients are placed in nodes of such grid, and we can monitor multicast traffic in grid architecture. Now we have a new proposal of multicast monitoring tool. It is being developed by my colleague from Poznan, Radoslaw Krzywania. This application discover multicast topology and present this topology to the user. We have some screenshot on this slide, example of such topology. Overview. This application based on SNMP protocol. We use now freeware SNMP library by Westhawk. In our opinion, is one of the best such SNMP library. We use also RRDD tool for storing statistic data and to generate charts. This is the same tool that is used in MRTG application. Also, it is implemented as in Java, so it is independent from OS platforms, and we plan to place sources on websites, so it will be open source application. Movie features. Basically, it is topology discovery. This application can start from one IP address, and using this one IP address of router, we discover all multicast network. We can monitor these routers in networks and links between them. Event message generation, if some events occur, statistic collection and presentation in graphical form, charts, simple MIB browser, and we used to deploy movie and IPv6 network as well. This is the first feature, topology discovery. You can see here example of such discovered topology. Application uses SNMP messages to query the nearest router, and this router has information about its neighbors, and then the application requests these neighbors, and this procedure is repeating, and that's why we can create all multicast topology of network. It is logical topology. If administrator has ability to change this topology, I mean this picture, you can, if there are many elements, many routers on such map, administrator can change place of such elements, shifts this elements. And this application also can monitor this topology, the routers in network and links. If link or router goes down, administrator of this application will see this change. Also, administrator may have ability to filter such multicast network. He can choose specific multicast group and only monitor this one multicast group in his network. Message generation. It's common feature. Application notifies administrator what is happening in his network. If links or router goes down, administrator may see this event on interface in such table, and the notification could be via email system. Statistic collection. Administrator of this application can define which parameters are interesting for him, he can select them, and he will have this values of this parameter stored in base, and he can see them on. He can see these values on charts generated using RRD tool. So these charts are the same as in MRTG application. Simple Mi browser. This clear. And IPv6 support. My colleagues has tested this application in IPv6 network, and using SNMP protocol, and these tests were successfully. But there are some problems with IPv6 MIPS. SNMP is in IPv6 is rather new topic, so we still research this. And of course, Java from version 1.4 supports IPv6, so also this application can be placed in IPv6 network. It is modular architecture. We have five modules: SNMP, display, event handler, what I said about message generator, statistic collector, and services. This application has defined some interfaces to add new functionality, new modules. It is not closed application. It's easy to add new functionalities, and it won't change all structure of this application. We can compare our application Movi with HP application. There are many similarities, and we can see this in this table. Some functions we still developing. Now we are doing test. We hope to present our application soon. We planned presentation earlier, but we were too much optimistic. We needed more time to implement a few modules, and we have some delay. Okay. In conclusion, we think that this application could be very useful in monitoring multicast network. Movie and multicast beacon may be important parts of multicast monitoring platform. So we think that people, network engineers that manage multicast network will find this application very interesting. What do we plan to do in this application? Well, first of all, we want to present this application for all. We have to change some algorithm elements in presentation. The tool should be accessed through GNI interface. There's small changes we have to do, and that's all.
Thank you very much. Are there any questions?
Thank you. Hi, just a very simple question really. About the multicast beacon code. Just wondering whether you're putting that back into the NLA, whether you're giving it back to the authors or whether you're making it available yourself, because they sound quite interesting, the extensions that you've done.
Mm-hmm, mm-hmm.
I mean, is it possible to deploy it? Is it on the web? Is it, or are you putting it back?
We have had some, as I said before, some changes, some new modules, and everyone can download our version of Beacon from our page, web page. I didn't place this web page on this presentation, but if anyone is interested, I can give this web address, and it is accessible to download our version of Beacon.
One comment about that one. I would say that we can see a kind of code branching in that particular tool, the Multicast Beacon. The original tool seems to be not developed recently. They started to re-engineer the original NLRNR code, but the development has stopped. That's why Poznan Supercomputing Center has decided to develop further, and it's available for free. Okay, thank you very much again.
Okay, thank you.